Hello and welcome to our second section in chapter 7, proportion properties. Now, in this particular lesson, we're going to talk about 3 different properties that proportions have. You may or may not have covered this in algebra, but in case you haven't, this is going to be a new lesson if you have seen these before, or if you understand the general concept of proportions, then this should be a breeze, and it should just be normal proportion, solving for proportions. Now, in the last lesson, I believe we used a cookie recipe that required 2 eggs. For every cookie recipe, I believe it was like 2 eggs to every 3 cups of chocolate chips, CC. And I believe I used this is the general ratio of eggs to chocolate chips. And every time we did this, if we wanted to create a new batch, let's say I wanted to double this value, we could actually, if we had, for instance, if we had in a refrigerator, if we had, let's say 6 eggs in the fridge, how many cups of chocolate chips would we need? And in this particular case, the properties kick in, and we actually could solve this using a number of different ways. For instance, we definitely know that in this particular case, it goes from 2 eggs to 6 eggs. That's 3 times as many. So we should realize that there should be 3 times as many chocolate chips. And in this particular case, it should be 9 cups of CC. And this is our answer, okay? Our properties here actually tell us this. We could actually rewrite this proportion as, we could rewrite this as a different proportion, and it would still be equivalent. Meaning, if I put, for instance, this is going to be our first property. We're going to kind of create a table. So this is our first property. And for the sake of it, let's actually make a table. So property number 1. So we're going to do 2 kind of tables. We're going to do the general form, and then the example of this. General form, and then the example. So in this first case, we're going to call this the reciprocal. The first method, reciprocal. Because what happens here is, if I took the reciprocal, if I call this A over B, or in this particular case, I'm gonna label this. Actually, let's do this in red. I'm gonna call this A. I'm going to call this B. I'm going to call the 6 eggs C. I'm going to call the 9 cups of chocolate chips D. And if I actually took the reciprocals of this, normally it would just read A over B is equal to C over D. Okay, so this is kind of the abridged version, or the short version. So you could just see it without the cups. If we took the reciprocals of this, the reciprocal means take the fraction, you flip it. This would actually be B over A is equal to, and then the reciprocal of C over D is D over C. And this would actually work as well as a problem. The reason why this is because if you really take a look at this, when you cross multiply to solve, right? A gets multiplied with D, and that actually still happens here. A is still multiplied with D. C gets multiplied with B, and that also happens here. C multiplies with B. So if I wanted to rewrite this entire equation as, and when we first started this, we actually had 2 over 3, so we could write this as 3 over 2 is equal to, we had 6 eggs to start, 6 eggs, and then we had an x here. We could actually solve it this way as well. And then you will still get this exact same answer, 9 cups of chocolate chips. So this is the alternate way to set it up. One alternate way to set it up, okay? Because 3 still gets multiplied with 6, as it does here. 2 gets multiplied with 9 or with x before we solve for it, and it would still result in the same answer. So you could the whole idea behind this is that you could actually solve proportions setting it up differently. So this is just one version of it, okay? original version, and then the reciprocals. Those also work. So don't be afraid if the way you set up a problem is different from the way a classmate sets it up, okay? Now, another alternate way to do this is actually switching the means. What this means is, no pun intended, this is method 2, switch means. Okay, so if I have this original A over B is equal to C over D, that's over here. What I mean by that is I'm going to actually switch their positions. I'm going to put B where C is and C where B is. Okay? So here, let's actually draw another box for here. And let's do this in blue, might as well. Instead of having A over B, I'm going to have A over C. What this means is actually the eggs will be on top of the eggs. And you'll see what I mean in a second. A over C is equal to B over D. And notice when we cross multiply, A is still getting multiplied with D. B is still being multiplied with C. The only difference is how we set it up. Ultimately, the same things are getting multiplied. And I'm going to put it or here. You could also set this up by switching A and D around. If I switch these two around, it would still result in the same thing. Switch those means. So I'm going to put D in the top over B is equal to C over A. And ultimately, the same things multiply. A multiplies with C, or A multiplies with D, C multiplies with B, and will result in the same answer. In this particular case, it does seem weird because eggs will be over eggs. We'll have 2 eggs, and I'm going to use this first example. 2 eggs will be over 6x. What this is just showing you is this is going to be your recipe. Wow, that's terrible. Versus actual. So the recipe calls for 2 eggs. The actual, what we're actually making is what we have, 6 eggs. And in turn, we're going to compare that with the chocolate chips. A recipe calls for 3 cups of chocolate chips. But what we actually have or need will be X, or in this particular case, 9 cups of chocolate chips. So hopefully this makes sense. It's just a different way to write it. And you do this by switching the means, okay? Because ultimately the correct things are being multiplied together. Okay, the last method is slightly different, and you're going to see this with triangles. And this one is going to be, let's call this adding the denominator. This one is slightly different. So if I take this original A over B is equal to C over D, if I add the denominator to the numerator, in this particular, let's do blue, or purple. It'd be A plus B over B is equal to C plus D over D. This, ironically, will also work, and you're going to see examples of this in, I believe, 7-6, when we're talking about similar triangles that have parallel lines. I'll do a quick example of one right here. Here, we're going to have 2 triangles, and these lines will be parallel. Let's call this A, B, C, D, and E. And the reason why I know that these triangles are going to be congruent, just take my word for it, these triangles are congruent. Triangle, not congruent, similar. Triangle CBD will be similar to triangle CAE. Okay? Meaning these angles are congruent, these 2 angles are congruent. If I give CB a length of 5, and then BA a length of 2, okay? At the same time, if I gave CD a length of Will be, actually 5 is a bad number. Let's choose 6. And then for here, if I chose, let's do 6 and 3. This would actually be better. 6 and 3. And if I gave CD a length of 4, what would be the length of, actually, I take that back. 6 and 2 would have been better. If I gave this a length of, let's give this is a full length of, let's say, yeah, 3 would work. 3 should be fine. Now, here's the idea. Here we have 2 triangles that are similar. We have a big triangle that is similar to a small triangle. Okay? And in this particular case, A plus B represents this whole length. So in this particular case, we could say that the whole length of that particular side is 8. It's 6 plus 2. Over this length, the smaller triangle, 6, is equal to this whole length. We don't know what this is, so we could call this x. And this would be 3 plus x over 3, right? Because we're talking about big to small, big to small. And that's the exact ratio we have here. And then from here, we could actually solve for it. If we do solve for it, we should realize that x will be equal to 1. If you don't believe me, try this out. But ultimately, these are the properties that we need to know. Primarily, you're going to work with these 2 to start off with. We're going to get into this fancier one towards the end of the unit. So just know that we could set up proportions differently. Don't be shocked if the way you set up a problem is different from the classmate. That's all I have for you today. We're going to get a whole bunch of more practice in with proportions, setting up proportions, and like I said, don't be afraid that yours is set up differently than a classmate's. It could still be right. It's just a different way to set it up. All right, I'll see you in the next one. Bye.